Thank you for having me here. It's a real honor to speak at this wonderful event today, especially as first speaker. So I'm going to tell you a little bit about building chatbots, and especially from the customer communication perspective, which is one of the things that we focus on most at Swisscom. And I want to start with a little anecdote from my experience working with enterprise customers at Swisscom. So as part of a pre-sales visit with a banking customer, I got to spend 1 hour just sitting next to a customer support agent in a bank, in an online bank. And I was just basically sitting there and listening into her conversations, not contributing anything, obviously. And I was really amazed at how much empathy this person had and how efficient she was in talking to these people and how helpful. Even though she was like just hanging up and the phone was ringing again, and I mean just constantly picking up calls without any pause and having to be helpful, cheerful, representing her company in a positive way. And after 1 hour of this, I must say I felt completely exhausted, even though I hadn't done anything at all, just listening in. And for her, it was just, you know, coming around lunchtime. Maybe she had a break, maybe not. She had to continue doing this for the whole day. And it really made me realize how, on the one hand, how important the job of customer communication is, because it represents the face of the company, and at the same time, how hugely undervalued it is. And the reason why I'm telling you this story is because I think because of the artificial intelligence hype, there is a lot of hope for these kind of jobs to be replaced. A lot of people are scared about it. But I think this story shows that it's really difficult to replace communication, because besides being able to, you know, just objectively understand what someone is telling you, you need empathy. You need to understand someone's frustration. You need to be able to read between the lines and to interpret silences. And you need to understand and show love in communication. And despite amazing advances in natural language, so this is a recent benchmark called GLUE, which now is no longer at 80.4, but something like 83%, where humans as a baseline are around 87%. So we're reaching almost human level natural language. So despite these advances, machines still have an immensely hard time in a lot of things. For example, understanding context. So this is what happens when you ask the Google, or what happened like 1 or 2 months ago. I just checked this morning coming into the conference, and now it's doing a better job. I've used this in many presentations, so maybe that had an effect. So it's very difficult to understand context, and also it's very difficult to empathize and to understand emotions. So again, and I have another funny one, which I haven't shown here because I found it recently. A bot from PayPal. Someone talks to the bot and says, I think I've been the victim of a fraud, and the bot's response is, great. So that's where we are with bots today, and really despite advances also in emotion recognition, it's still not there yet. So emotion recognition of 6 very basic emotions is currently at 60%, and that's by far not enough. Especially when you also consider the fact that bots operate in text, and it's really difficult even for humans to properly understand texts, let alone for bots. So can we still do something useful with bots? And I think the answer is a definite yes, but we really need to do it a bit differently. And my experience so far has been that we need a different flavor of data science, not necessarily just for bots, but more generically, which I'd like to call human-centered data science. And let me dive right into it and tell you why I think this is necessary. So what exactly do I mean with human-centered data science? I want to start with the part that we all know very well, so the data science part. From a recent, that was a heart up there. I don't know what happened to it. From a recent survey from Kaggle, it seems that this is what we spend most of our time doing. So a lot of time goes into cleaning data, gathering data, visualizing, etc. Then we spend some time building models, talking to people a little bit, and then putting models into production. And if we look at it more from a workflow and a process view, let's say, it looks a little bit like this. So we get typically a business problem from stakeholders, from business people. We collect data. We do all the stuff that we need to do with it, visualizing, cleaning, etc. We build some models based on it, or we analyze or build some visualizations, whatever is needed. We maybe circle back to the stakeholders, explain, maybe we have to adapt the model to the situation that it's being used in. And finally, once we get validation, it can go on and be used. And now, what about the human-centered part? So I don't know if many of you are familiar with the human-centered design process. It looks a little bit like this, and it's a methodology to develop products, basically. So it starts with empathizing. In order to understand what you're building, you need to understand the needs that it needs to address from your users. It continues with defining. So with empathizing, you go very wide. You collect a lot of data about users' needs, and then you need to kind of focus and find out which ones are the most important ones and really focus on those. And then again, you kind of go wide and kind of trying to brainstorm a lot of ideas about what possible solutions for that problem could be. Then you build a prototype. You do several rounds of testing your prototype with those users, and well, then maybe you have a product. And I think there is a very strong parallel to be drawn with the data science workflow. And I was really fortunate to start my data science career in the human-centered design of Swisscom. This is where this is coming from, basically. And unlike in perhaps many other settings that you may be familiar with, as a data scientist, I was not the star of the team or of any kind of group of people. It was the designers, because it was really their job to make sure that the most important part of the project, which was basically making sure that we're solving the right problem, was done. And so to draw the parallel with our data science process, I think it's very, very similar to what happens in human-centered design. So in human-centered design, we empathize with our customers. In data science, we need to understand our stakeholders. In human-centered design, we need to define our problem to kind of distill it from all the information that we get from empathizing. The same in data science. We need to explore our data, we need to clean it, we need to visualize it, and so on. In human-centered design, we need to come up with ideas for solutions. Again, very similar in data science. We need to brainstorm which part of our tool set we're going to use for this particular problem. Then we prototype, and then we test exactly the same as we do in data science, with iterating over our models and gathering feedback and so on. So to come back to why we need human-centered design in data science, and especially in designing chatbots, I want to give you an example of how I think we've applied this in building artificial intelligence products for customer communication. So I think, again, we start with the problem. As a data scientist, we get a problem from our business stakeholders, which often looks something like this. How can we optimize customer support costs? How can we increase conversion rates? Maybe you've heard all of this before. But now, putting on my human-centered design hat, do our customers really care about these questions? I don't think so. They would probably care more about things like this, which are equivalent, but it's just a very different viewpoint. So how can we solve requests quickly and accurately? Or how can we help users figure out whether our product fits their needs? So we really need to look at both sides in order to create useful products in data science. And back to my data scientist hat, in order to solve these problems, we have a variety of tools. I am listing here all of the different components that we might use to build a chatbot. We have, for example, for goal-oriented or transactional bots, we have sentence classification or intent recognition. We have entity recognition. If we're looking at retrieval bots, we can build inverted indexes or dual encoders to rank the potential answers for relevance. We can use text-to-SQL to retrieve data from SQL databases with natural language. We can use encoder-decoders or transformers to generate answers automatically. And of course, we also need to do dialogue management, and we also need to handle cases that the bot perhaps is not equipped to understand. And we sometimes also use rules, which is perfectly okay. So what exactly can we do, given this set of tools and the problem that we are given and that we understand? Well, we always start quite simple. So one first very, very simple bot could be just building an inverted index. It's basically a search engine, but put a bit in a different way. So you ask a question to the bot tries to retrieve the answer that is most relevant to that particular question. It's basically Google, what used to be voice search. If we go a little bit more sophisticated, we can build a goal-oriented bot. So it's a bot that can do something for us, like classic example, reserve us a restaurant or a flight. And for this, we need first sentence classification, then entity recognition to retrieve all of the information that we need for doing that action. So what kind of restaurant or destinations of the flights, dates, and so on. And typically, we use a static flow because dialogue management is still quite complicated with machine learning. And then finally, going a bit even a higher level of complexity, if we want to handle even more cases, we can combine both things. So we can have both intent recognition, and we can have fallback intents that rely on inverted indices or on some other way of classifying results from knowledge base of results. And we can also experiment with dialogue management based on learned policies. So in an enterprise context, for perhaps those of you who work in that context, we usually start with the very, very simple cases. And this is also what we did at Swisscom. So we basically, looking at the call center, we have agents who already have quite a large base of knowledge and of data in different parts of the IT system. And the first step is really to put all of these together and give them a retrieval bot, which functions like a search engine over all of these sources. And this bot already can bring a lot. So given the agent's experience and this little engine that we're giving them, this results in a really nice speed up of the agent's workflow. But now, of course, if we wanted to expose this to our real customers and have people talk to such a bot, it would definitely be very underwhelming. And we can clearly see this if we put on again our human-centered design hat and start all of these, answer all of these questions. Like, what can the bot do? It can just spit out a pre-given sentence from a database which might not actually correspond to any actual question. Why should I use the bot versus other options? So often you have frequently asked questions pages which are much more easily accessible, and you can have an overview of what information is there versus a bot where you don't necessarily know what you can expect from it and you have to explore. So it's in this form, it's not necessarily that much more convenient. And I was just talking to Bianca earlier, and she was saying that her experience with bots was that it's not very useful, though it's funny. And I was just thinking, yeah, it's funny, but we don't actually laugh with them. We mostly laugh at them. And it's a kind of, at least in my experience, recurrent behavior when people really try to make bots fail. Okay, so how could we make it more useful? This is the next question. And the answer comes from the data science part. So we already have quite a good idea of what kind of requests we receive in our customer support center. It looks a little bit like this, maybe a little scary. So we have hundreds of classes of requests which are classified in a manually created taxonomy, which doesn't necessarily reflect that much similarity between these requests, as you can see from this plot. So that is one problem. But what it shows us is perhaps the ones that come up the most commonly and what kind of requests these are. And with this information, I think it becomes much more easy to take, let's say, the top 3 of these requests and try to include them in the capabilities of the bot. And by doing this, the hope is that we can make this bot a lot more useful, since it can handle a much higher volume and a higher variety of requests. And these are mostly transactional requests. So things like, I want to order a phone without a contract, how much is it? And then, well, the bot has to kind of get more information, what type of phone, what color, whatever. And this kind of request needs to be handled in the goal-oriented paradigm, which I've spoken about before, but here's another more concrete example. So the first step in the goal-driven bots is identifying the intent. So you have a list of things that you can support. Like I said, in our example, maybe the top 3 types of requests that you get in the support center. So first you need to classify to which of these the sentence belongs. And once you have this, perhaps you also need additional information to complete the transaction. So where, what are the destination and the origin of your flight, which date, what kind of restaurant are you looking for? In our case, what kind of phone do you want to buy? Or what kind of contract do you need, or what kind of add-on, and so on. And once we've built this little bit more complicated bot, which can handle both our transactional requests, but also give answers to frequently asked questions, I want, again, to put my human-centered design hat on and ask these questions again. So what can the bot do? Well, now it can do a lot more. So not only can it give you purely informative pieces of information like, I don't know, what is the link for changing your password, where can you find information about product XYZ, but it can also help you actually get things done. Why should I use the bot versus other options? I think here there's a lot to say about from where you're accessing this bot and how this fits in your typical interactions with your phone or your computer. So personally for me, if I have to open a special Swisscom or Swiss Re or whatever other app and log in and, I don't know, go search somewhere for information or for a way to do a transaction, this is a very complicated and very off-putting process. Whereas if I can go to my WhatsApp account, where I anyway spend a lot of time talking to my family, my friends, my colleagues, or to, I don't know, SMS app or whatever else you're using for communicating with the people in your life, well, this becomes a lot more convenient, right? Because you can just go there and speak to Swisscom or to Google or to whoever else as you would speak to any other person in your life. So it's suddenly a factor of convenience that is very important. Cracking jokes. I think, again, this is really a very nice feature. Bots making us smile, it has value, but it needs to come alongside managed expectations. So I need to know what I can expect from this bot. I don't want to be constantly trying to guess what the bot can or cannot do for me. And again, how fast does it solve the problem? This goes back to why should I use it versus other options. If it lets me solve the problem faster than other ways do, then it's a huge win. And I want to end with 2 examples of bots that I think are quite successful at doing what they're supposed to do. One is the Starbucks bot, which is very, very simple. And you see this right from the start. So manage expectations, tick. What this bot can do for you is basically you pick your coffee or your drink or whatever else you want to order from Starbucks on the go or from wherever you are. By the time you get to Starbucks, your drink is ready. You've paid for it. You can just pick it up and go. I find this very, very convenient. And if this were available in Switzerland, I'd probably be a big user of it. And the second one is one that we're currently experimenting with at Swisscom. And it's meant to do exactly what I've just described before. So basically, taking in the most commonly encountered customer requests and providing a very convenient way of solving them. So for example, you're traveling outside the country and you need to buy a roaming package. You can do this very easily inside of this bot, or you want to change your subscription, or you need technical support, whatever. These are a couple of the use cases that it can handle. So, okay, here are more examples. Basically, and the convenient part is really because we know from which phone number these messages are coming. If we're doing this interaction via SMS, you don't need to do any logging in or any other kind of inefficient interactions. So to sum up, I think the takeaway message that I want to transmit you today is that as data scientists or as technology professionals, we tend to place very little value on, let's say, the soft parts of developing products. And I think we can do a lot better, and we're expected to do a lot better because the data science profession has typically been seen as a kind of messiah, a person that can come in and solve all of your problems and understand everything and provide solutions to everything. And if we are really going to live up to this expectation, then I think we need human-centered data science. Thank you very much.
So how do you handle this challenge of having several Swiss languages with the different dialects?
Thanks a lot for this question. Really great question, and I cannot say that we've solved this challenge, but we're really working on it for several years now. And the challenge is not only that we have several dialects, but much more that Swiss German is a spoken language. So that means that looking at speech recognition, we don't really have a lot of data to work with, because people don't really, first of all, they don't transcribe it in the same way, and second, well, they don't transcribe it at all. So we're putting a lot of effort in gathering data for this. And then I think for the chat part, this is really going to first need some kind of translation that standardizes a little bit what the customer said towards High German, so, or what we call Swiss Standard German, and then understand this with models meant for High German, and then being able to answer in Swiss German.
And the second question is that what you presented is mostly from text, so there is no speech involved right now.
No, yes.
Okay, thank you.
But we are working on speech as well, so I did not include it here because I thought it's easier to get the point across by focusing on one.
Thank you. Thank you so much.
Yeah, thank you.
Hi, thank you for the talk. I have two questions as well. So for the rules, you mentioned that, yeah, it's okay to have rules. And I was wondering what percentage of rules do you think should be acceptable? And how much bias do we introduce by those rules? And yeah, that's the first question. And the second question is, you showed the example with the flights. And in my opinion, sometimes the system doesn't have enough of the objectives that the person has. So for instance, sometimes I might change my opinion of not having a stop given the duration of the stop in the flight or the price or many other constraints that in a multi-objective optimization problem, maybe the bot doesn't even have those objectives. So how would you, when would you imagine that we have a solution for that?
Great, thanks a lot for the questions. Should I already forgot the first question? Okay, so let me start with the second question. Multi-objective optimization, that is a really interesting problem. And again, I cannot claim that we have a solution for it today, but we do have a very active research lab at EPFL and starting one at ETH that is working as of a couple of months ago exactly on this problem. So basically, but more in the context of recommendation systems. So how can we build systems that, as you said, take into account several objectives, and especially in the context of fairness, where you not only want to recommend fitting products, but you also want to make sure that you don't, as in the case of Facebook, which has become famous over the past few days, that you don't only advertise nice homes to white people. So we're really tackling this problem from the fairness angle, and I think, well, I don't have an answer how we solve it, but we're really working on it. And then about, I just remembered the first question. About the rules, I don't think there is a rule, pun intended. I think I am very, I'm a very big fan of pragmatic approaches. So if you can solve a problem efficiently with 100% rules, then go for it. Who cares? I mean, in the end, what matters is the result. And well, in the particular case of bots, I think at least what you could claim would be rules where, for example, the static flows that are often used and that are currently more and more combined with learned policies. But sometimes you just don't have a choice, right? So I cannot say that 50% rules is okay, but 80% not. Just be pragmatic. All right. That's it for this talk.
Do you want one more? Do you want one more question?
Yeah, that's
Hi.
all right.
So last question, please. Can you hear me? Okay. So I wanted to know typically how many dialogue turns or exchanges does it take till you connect to a live customer agent? And do you consider, sometimes personally in my experience, many times you just want to get connected to a live customer agent during chat conversation, but you have to answer certain mandatory questions to get there. Do you, take those kinds of textual exchanges in consideration? Like how can you basically make it more efficient for the customer?
So I think the goal in making the chat useful is really that they don't need to connect to an agent at all. And if you find yourself in a situation where you're looking for a way to access a human agent, then we failed with the bot, right? That said, of course, it should be easy for the person to connect to an agent just by simply saying, I want to talk to a person. And this is our goal. It's not really to block people from talking to other people, but to going back to the problem in the beginning that we've understood so well, to solve their problems fast and efficient. And, well, sometimes the most efficient way is just to talk to another person.